and sort of taking a different tack. So today I'm going to be talking a lot about work that's been driven by Julia Blanchard, who's a researcher here at ACEAS. And I'll jump right into it. So we've heard a lot about Antarctica and the Southern Ocean today, a very remote, cold, harsh place, and you'd be forgiven to think of it as being quite inhospitable to life, but that's really very far from the truth. It's the Southern Ocean hosts some of the most productive ecosystems on the planet, actually. So we have these immense phytoplankton blooms in spring and summer, and those blooms support enormous biomasses of secondary consumers. And so secondary consumers are things like fish, squid, krill, and these biomasses of secondary consumers then in turn act as really important prey for a whole swath of iconic marine predators. So our penguins, our seabirds, our seals, and of course the large whales that we see migrating up and down our coast. The other thing is that in addition to being incredibly important from an ecological perspective, they're also really important from a fisheries perspective. So the Southern Ocean has three major fisheries for Antarctic krill, toothfish, and icefish, and collectively these fisheries are valued at around $570 million a year. And this is all nested within an ecosystem or a system that's overall valued at around 275 billion. So it's incredibly valuable place, incredibly valuable ecologically and commercially. And yet we still have very little understanding of how these systems are likely to respond to this really rapid climate change that's happening. So one of the ways we can get a glimpse of what's going to happen into the future is using marine ecosystem models. So marine ecosystem models simulate the important links between the physical environment and ecological processes, and they really provide us the capacity to run risk assessments into the future of future ecosystem state, fisheries biomass, and all of that kind of information under different climate scenarios. And so one of the major projects that's dealing with this is this project called the Fisheries and Marine Ecosystem Model Intercomparison Project, or FISHMIP for short. And this is a project that's being led by Julia Blanchard. And so what they've done is they've assembled a state-of-the-art ensemble of 9 global marine ecosystem models, and they've coupled them with 2 Earth system models to run these next-generation projections of ecosystem responses to climate change. So they've done that for the whole globe, global oceans, and they've done that. Their latest iteration was published in the FAO, and it was looking at high and low emission scenarios. And I'm going to talk a little bit about the work that came out from that focused on the Southern Ocean. So these are the projections from the model ensemble for the Southern Ocean. Everything in blue is where we're expecting fishable biomass to increase. This is for a high emission scenario, about 2100, by the way. And then everything in red, orange is where we're expecting decreases in biomass. And everything in stippled gray is where we have high model disagreement. So I'll come back to that. But what you can see is there's a huge amount of spatial variability in our projected responses. So closer to the continent, we're seeing projections of increased biomass, whereas further north in sort of subantarctic waters, we're seeing declines. And just about the entire Southern Ocean is covered in grey stippling. So we've got a huge amount of uncertainty associated with this. But where we have higher certainty or less uncertainty is generally where we're seeing declines in biomass. So if we focus in on one of Australia's key strategic areas of interest, which is the Heard and McDonald Islands area. So this is where there's a important toothfish fishery worth around $100 million. What we see is there's generally quite good agreement that biomass is going to decline. And under high emission scenarios, biomass could decline by as much as 30%, which would equate to about $30 million in lost revenue. But the other really important thing is that under low emission scenarios, we can actually reduce that biomass loss by up to 80%. So it really shows the value in tracking towards our net zero targets. But yeah, coming back to the grey stippling on the left, the next stage is really to try and rein in that uncertainty that we have. And so that brings us to another project that's being led by ACEAS actually so one of the issues with these global models is that they really struggle to capture processes that are very unique to the Southern Ocean. And so what we're doing is we've got the Southern Ocean Marine Ecosystem Model Ensemble, or SOMEM. And the idea behind that is to incorporate into the global model ensemble a suite of purpose-built regional Southern Ocean ecosystem models. And so SOMEM has brought together a global community of ecosystem modelers, and we've assembled over 10 regional ecosystem models to feed into it. And so we've also developed a roadmap towards integrating those models into the broader FISHMA protocol. And so each of these models captures different elements of the Southern Ocean, specific Southern Ocean processes in different ways and at different scales and resolutions. And so I thought I would just touch on two of these models that we have being developed by ACEAS. The first of these is being developed by a fellow postdoc, Kieran Murphy. It's called a MISA model. It's specific to the Pryds Bay region, and this model captures all the components within the food web for the Pryds Bay area, all the way through the water column all the way to the seafloor, and looks at each of these components and how their biomass changes over time and under different pressures. And one of the great things about this is we can look at changes in one or two components of the ecosystem and how those changes manifest out to the food web more broadly. And so we can ask questions around, for example, how does a recovering whale population after the end of commercial whaling lead to increased consumption of key prey species like krill, and what does that mean for the ecosystem, and what does that mean for a fishery that we want to keep sustainable? The other model that I'm going to highlight is a shameless plug for myself, and this is a model called krillpidum. So this is one that I've been developing, and this is very much focused on a key species of key Southern Ocean species, Antarctic krill. It's arguably one of the most important species, or the most important species in the Southern Ocean. And this model really focuses on trying to represent the very specific requirements, habitat requirements krill has in its environment across its life cycle, and use that to generate very high resolution estimates of its abundance and its distribution and how that changes over time, giving us some capacity to understand how a changing physical environment could manifest in changes to its distribution and the consequences for dependent marine predators. And then, so we've got this network of regional models that are really poised to start generating the next generation of projections for the Southern Ocean in terms of biomass change over time. The other thing that FishMap's been developing is a way of making those data available to the broader community and end users. And so this is the Southern Ocean Projections Explorer, but I also want to make a note that these data are all also available on CMAP Antarctica, and there's a QR code over there for that. Unfortunately, I don't have the image of those data layers on CMAP Antarctica here, but check that out. And so the idea is to make these data layers available to end users for use in future risk assessments for these ecosystems, ecosystem services, evaluations, and things like that. So we really want that to support decision-making and key stakeholders, the Australian government, but also organisations like CAMLR as well. And that's all I have. Thank you.